Hi, I'm Chae-hoon, and today I will talk about the solar cell, silicon solar cell. And our presentation in this order: silicon solar cell manufacturing process, and solar cell IV curve and field factor. First, this is totally manufacturing process of the solar cell: vapor processing and texturing, emitter formation and oxide removal, and AR coating and metallization, firing, and last is etch isolation. But today I will explain about the texturing more deeply, and the main subject is texturing. And another process I will briefly simple, and I will move on. So let's talk about the solar cell mechanism first, and additionally the structure of solar cell. The solar cell structure is mainly with the p-n junction, and the mechanism is when we shoot the light at the p or n region, there is a product, the electron-hole pair, and the electron-hole pairs are recombination with hole or electron at the p or n region, but there is no recombination with electron hole pair, and that remain the electron hole pairs are the subject operating source of the solar cell mechanism. And I will talk about this mechanism after the texturing. And let's talk about the texturing of manufacturing process of semiconductor, solar cell semiconductor. And the first figure is the normally semiconductor of the solar cell, and we can see that the light are past the semiconductor, and that is lower efficiency of the solar cell operate source. So we need the texturing the semiconductor surface or edit the rare reflector like this second figure. And the second figure shows that when we edit the rare reflector, the light are more longer stay at the semiconductor of solar cell semiconductor, and that means why we increase the stay time of light or at the solar cell semiconductor. I explained that previously. When the light is stay longer at the semiconductor, the electron hole pair producing time is also increased. So ultimately the efficiency of solar cell is also increased. So let's see the next figure. This is when we texturing the semiconductor surface. We can see that the picture that the light is more stay longer at the semiconductor, and finally that last figure is also show that the light is more longer stay at the semiconductor, and that means is the producing time of electron hole pair is increased, and that produced electron hole pairs are the main source of the operating the solar cell semiconductor, and that means the photo generate current are increased. So the last figure is the texturing the rare reflector and the semiconductor surface also. And let's talk about more deeply about the texturing. And this is about the this is structure of the silicon diamond structure. And first is 100 surface of diamond structure of silicon, and the next is 111 structure, 111 surface of the silicon diamond structure. And why I choose these two figure, that is mainly at the surface density. Oh, this next figure is about the surface density of 100 silicon and 111 silicon, and we know that the 100 surface is more lower than the 111 silicon surface. That surface density is more lower than this figure, so we can more easily texture the silicon surface when we get the 100 surface. So the next figure is the surface of solar cell semiconductor, and we can see that the structure is like shaped with the pyramid, and this pyramid shape makes the more increased of the solar cell efficiency. And additionally, when we texture the pyramid shape like the lower, smaller or bigger than the 10 micrometers, maybe when we product the solar cell, the 10 micrometers pyramid shape is best of the efficiency of solar cell semiconductor, and when we get the bigger or smaller size of pyramid shape, the efficiency is lower than the previous case, and maybe the wafer is weaker than the previous case. So the ultimate goal of the solar cell semiconductor texturing is 10 micrometer shape of the pyramid. And next I will see another graph of the reflectance and wavelengths. We can see that the graph that means the reflectance, and first case is bare silicon and 500 nanometer inverted nano pyramid, and this case is about with your ARC, and I will explain the ARC later. And first let's see that the reflectance is lower and lower when we edit the nano pyramid and the dual ARC. So let's see the 700 nanometer inverted nano pyramid with dual ARC is approximately within the zero reflectance, and that means when the light shoot at the silicon surface, the whole of the light is stay at the silicon semiconductor, and we can call that the black silicon. And next, let's see the ARC, and ARC means the anti-reflection coating. This is process of the adding the AR coating, and this table is using the ARC with the material, and maybe The most of using the material is dioxide or silicon nitride, and silicon oxide may be using at the AR coating. And this graph is when we use the ARC and we do not use the ARC, and we know that when the using anti-reflection coating is more lower the reflectance of more than the uncoated semiconductor. And let's talk about the metallization. The metallization is the process of manufacturing of the solar cell. And the first figure is about the silicon solar cell structure. And when we do not process the metallization, maybe the electron hole pairs are the collecting at the any places, but we get processing the metallization, the metal line are collected the hole and electrons. I said electron hole pairs, and collecting electron hole pairs is the processing of the solar cell mechanism, and we can call that metal line like finger, and this is the surface of whole solar cell. And this is the finger, and the finger can collect the electron hole pair. The most efficiency of solar cell is finger occupy this solar cell surface like maybe 4%, more than 4%, and the 4% of metallization processing is the best efficiency of solar cell, but the actual process of manufacturing silicon solar cell is 6% of the whole solar cell surface. And the next is firing. Firing is the contact line is get the contact line with firing, and we can see that the n-type silicon, p-type silicon, the best place of the contact line is the middle of the n-type silicon. And this is processing the firing of solar cell semiconductor. And let's see the solar cell IV curve. This case is about the solar cell IV curve when we do not shoot the light, and this is about the when we get the light at the solar cell diode. Let's see the first case. The first case is there is no light with the solar cell, and this IV curve is also make this like this shape, and we can see at the many times, and this graph means like the originally diode, but when we shoot the light at the solar cell, the IV curve are generated at the quadrant place, and the quadrant place are means the photo generate current is producing because of the shooting the light, and when we get the more strongly light at the silicon solar cell diode, the photo generate current are more increased previous figure, and we can see the increasing of the photo generate current. And this graph we can define the formula like this figure, And this figure means the whole current of the solar cell diode circuit, and this is the formula of the whole current of semiconductor. And we can focus on this n constant, and this n constant means the ideality factor of the solar cell. And the ideality factor of solar cell means when we operate the solar cell and emit the light at the diode, that the operate ideally, we can evaluate the solar cell operating system when we calculate this formula. And the n constant is about the ideality factor. That means how solar cell more operate like the ideal case. And this is about the positive voltage when we apply that at this circuit. And this case is about the when we get the negative voltage at the solar cell circuit. And this is the ultimate formula of the whole current of the solar cell circuit. And let's see the IV curve and the IV curve of solar cell and power curve of the solar cell. This graph is get this IV curve, and when we get the current this zero side, and this is when we get the zero voltage, and we can call that case is short circuit current, and this is open circuit voltage. So ISC and VOC means the maximum current from a solar cell and occurs when the voltage across the device is zero. That means the ideally operate the solar cell, we can get the maximum current like at voltage is zero. And the last topic is fill factor. And fill factor means actually we can get the ideally the power of the semiconductor, solar cell semiconductor. So the maximum power of the semiconductor is multiplied with VOC and ISC. And the actual case, like the generally case of the solar cell is divided with the VOC multiplied ISC. And fill factor means that the operating evaluate system is maximally divided with the power of the max place. And the fill factor is the best fill factor is the similar with this calculating number, and this calculating number are similar with whole calculate when we get to calculate the whole calculate. So that means the B area divided with A area. So the silicon solar cell presentation is the last topic is here, and thank you for listening my presentation.